All right, here's the lesson 3.2, using parallel lines and transversals. So we have one postulate and three theorems here. The postulate is the corresponding angles postulate, which says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. This does not need to be proven. We can use that in a proof without having to prove it already. So we know that the corresponding angles are congruent. Now we have the three theorems here, which can be proven, and we're going to prove one of them. Alternate interior angles theorem says if two parallel lines, so notice the key here in all of these is that we're talking about parallel lines, not just any two coplanar lines. They have to be parallel. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So we're going to prove that in a second. Alternate exterior says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So far, the corresponding, the alternate interior, and the alternate exterior angles are congruent if the two coplanar lines are parallel. The last one is the consecutive interior angles theorem, or the same side. Remember, I said same side instead of consecutive in the last example or last video. If two parallel lines are cut by a transversal, then the pairs of consecutive angles are supplementary, not congruent. So make sure you pay attention to that. So now that we know the relationships with these angles, we know how to identify alternate interior, exterior, same side interior, that kind of stuff from a diagram. Now we know some things about those specific angle relationships. So we're going to prove the alternate interior angles theorem. So here is what we're given. We're given that P is parallel to Q. Okay, so that symbol there, you need to know that that means parallel. And we have a transversal T. So the transversal cuts the two parallel lines. We're trying to prove that the measure of angle 1 equals the measure of angle 2. So you can see that how I labeled the diagram with 1, 2, and 3. So if I'm asking you to prove an angle congruent to something else or equal to something else, then I'll either use letters and give you the name of the angle, or I'll give you the numbers so you kind of know what angle I'm talking about. So we have our given statement written already. So for our second step, why don't we use the postulate that we just talked about? So which of these are corresponding angles? Angle 1 and angle 3. So the measure of angle 1 equals the measure of angle 3 because of the corresponding angles postulate. Again, we do not have to prove that. We can use it in our proof. Now, I also see vertical angles here. Measure of angle 2 equals measure of angle 3. That is the vertical angle theorem, which we already proved. So I have that 1 equals 3 and 2 equals 3. Therefore, I can conclude if 1 equals 3 and 2 equals 3, that 1 equals 2 by the transitive property. That's it. That's the proof for alternate interior angles theorem, and it would work very similar if you did the alternate exterior or if you did the same side interior, except remember, the same side interior or consecutive interior, those are supplementary. So make sure you pay attention to that.